Okay, we're looking at the law of sines, the ambiguous case, or side-side angle. We're going to look this time at the no triangle case. Good news there, I guess. I'm Jody DeVoe, and let's take a look at our first problem. If you haven't already done so, I'd recommend watching the first two parts of this pencast where we go through the one triangle case and the two triangle case, because I'm going to assume that you've already seen those when I'm doing this solution. Okay, so our problem looks like this. We're going to say side A is 12, side B is 23, and alpha is 34 degrees. Okay, so we're going to draw our triangle, and it may or may not be accurate. I guess it's going to be not accurate since we already established that this is going to be the no triangle case. So I have alpha equals 34 degrees. So side A over here has to be side length 12, and then B is over here, and that one is 23. Okay, so this angle down here then has to be beta, and the angle up here has to be gamma. Okay, that's alpha and beta and gamma. Okay. So let's give this a try. I'm going to say, let's see, the sine of 34 degrees over the side opposite, which is 12, equals the sine of beta over 23. Now again, remember why this is the ambiguous case. It's because we're given only one angle. Only one angle. That's the thing that makes it the ambiguous case. I don't know the other two angles, I'm only given one. Okay, so when I go to solve this, then I find the sine of beta equals 23 times the sine of 34 divided by 12. And I get the sine of beta equals 1.07. Now, I go to my calculator, use the inverse sine button on the calculator, and that fact right there, again, is the thing that makes this problem the ambiguous case. When I hit that inverse sine, I have to solve for the angle. When I solve for this angle, beta, the sine of beta equals 1.07, you'll get an error on the calculator. Domain error, I think is what it will say. That tells us it's not possible. There are no triangles possible in this case. And you probably should have known that before you hit the inverse sine button. Let me remind you why you might know that. I'm looking to solve this equation, where is the sine of beta equal to 1.07? And again, the sine curve waves around the x-axis like this, and the highest it ever gets is 1. Now I know that's close, it's 1.07, but 1.07 is above 1, and so there will be absolutely no place here where that line intersects the sine curve. And it's for that reason that when you hit the inverse sine button, you get an error, because the largest the sine wave ever gets is 1. So when you say sine of beta equals 1.07, there's no solution to that. Since there's no solution to that equation, there are no triangles. Okay, so we're in the no triangle case here. And we're done. Okay, I hope this 3-part series helped you out, and we'll see you again. See ya.